Welcome to this session. My name is Dong Wang. I'm the Chief Database Engineer at PayPal. And joining me together today, we have Van, who is a lead database engineer working at Venmo, and Heidi, lead database engineer working at PayPal. And today we are going to talk about how we scale the MySQL systems at Venmo, specifically to addressing this year's scalability challenges. And before we start talking about the MySQL specific stuff, we want to go through what we are going to cover today. We'll have a very brief introduction about Venmo and what it does as a business, and we'll survey the Venmo history, covering the application ecosystem and MySQL architecture, and also describe the challenges that we face this year for the scalability side, and short-term, long-term improvements that we made throughout the activities that we done from late last year. And we'll wrap up with a Q&A session. So to start with Venmo history, I'm sure that many of the audience sitting in the room are the Venmo users. It started as from a freshman roommates from UPenn, they have their need to send money to each other. It get a very primitive started with the text messaging to be able to send money to each other, but quickly changes into a very widely adopted smartphone app. And in 2012, the company was acquired by Braintree, and later on, Braintree was acquired by PayPal. So Venmo right now is a PayPal service. As of this year, Q1, Venmo has a large user base. It has like 40 million users actively using Venmo, and it's accounted for a large percentage of PayPal's overall user base, as well as the revenue contributions. And it grows exponentially every year. So not people can do the P2P money transferings, but we are trying to leverage the Venmo platform also for the payment side. So you can use Venmo to pay for the services and merchandise. Challenges for Venmo scalability are coming into two aspects. One is the challenge from the active usage of the system by the users, such as we have a growing number of active users, growing number of users, transaction volume, and growing data size. The other side of the challenge is from the business development, right? We always introduce new features into the system and increasing the fraud detection capabilities and security of the system, reduce the frictions between the user, improve the user experience, and keep what Venmo unique as the social app to provide a good user satisfaction. So if you look at the volume growth, this shows some historical data about the payment volume that it made on the platform. On the left side, it shows this quarter by quarter growth is showing a exponential growth. This, even though at the end of Q1 2018, it's already contributing like more than $12 billion to the overall processed volume. And on the right side, it shows the shares of the Venmo users who make a monetizable transaction is also growing rapidly as well. And considering this exponential growth pattern and considering the overall start-up history of Venmo and small number of engineers working in the system, we're facing a tremendous challenge of how do we scale that to meet the exponential growth year over year. So especially during the over years time, there is a particular day that is having a peak traffic volume, which is the Super Bowl day. And we are going to talk about how do we prepare the system starting from late last year as a joint effort between the PayPal core business side and the Venmo side. So that's how our DBA teams work together to collaborate on scaling the Venmo system. So with that, I'll transition into Heidi to describe the Venmo general architecture and addressing those challenges.
The next couple of slides, I will go over the Venmo's application ecosystem and the database architecture. So here you can see that Venmo's entire infrastructure is in AWS in multiple regions. And the Venmo offers multiple interfaces for the customer to perform payments. The mobile apps available for the iOS and Android, and the web admin interface, and internal tools for customer support, and also the developer API for integrating Venmo's payments with the third-party mobile apps. All the client interactions is driven by the backend API endpoints, and the backend API is pure Python with monolithic application design, which uses Django for ORM and database transaction management. In the routing layer, the NJX and Envoy are the elastic load balancer in front of the application instances. In the messaging layer, you can see that the Celery handles the asynchronous tasks that's outside of the request lifecycle. And Redis is used as the Celery message brokers with multiple queues for different types of tasks that's processed by the task workers. So the backend application instances, they rely on a number of internal interfaces and external services. So for example, every Venmo P2P and pay with Venmo transaction generates the risk variables through either the internal API or Celery async tasks. And those risk variables rely on the PayPal's REST endpoint for the risk evaluation. So based on PayPal's response, the transaction is either rejected or approved. So when scaling the Venmo's application, the performance and the integration of the external services is also critical. In the database layer, you can see that there are multiple Aurora MySQL clusters for separate domains, such as the core payments, authentication, OFAC, and also Venmo's social backend, like a social graph, feed, user. The binlog replica is set up between the Aurora clusters within the region for analytical and reporting purpose, and also cross the region for DR. The MongoDB manages the public, friend, and user fees, profile fees, like including the payment and transfers. The Cassandra handles the write-intensive events use cases, like the login events and the address book. The Elastic search clusters are used for the fast searches for usernames, friends, and some of the graph-centric operations. So as you can see that to scale a large-scale, multi-tiered web application, each layer in the ecosystem needs to be scalable elastically to handle the growth of the application and also support the occasional surge in the activity during some peak events. So from the application layer to the load balancer, to the caching and the messaging layer, to the backend database tier, Venmo team did a holistic approach to scale the entire platform. So let's, I'm gonna take a look at, okay. All right, so let's take a look at Venmo's application framework. So in the application backend, Venmo uses Django's MVT, the model, view, and template framework. So the Django has built-in models and ORM. The ORM basically allows the developers to to write the code without actually touching the backend underlying SQL. The Django's ORM uses a lot of abstract ways to generate queries. While it provides a common interface for data operations, it does add risk of generating insufficient SQLs and also add more SQL calls to the database. So we're going to go over in more details when we talk about the query tuning. Okay. Okay, so the database architecture. So in 2017, Venmo migrated the MySQL on EC2 to Aurora MySQL cluster. Currently, Venmo runs all their MySQL databases on Aurora in multiple regions. So I'll quickly go through some of the features of Aurora. On each of the Aurora cluster, there is a primary instance, and that's basically the writer. So it performs all the data modifications, and on each of the cluster can have up to 15 read replicas, which connects to the shared storage volume. And the read replicas, they're spread across 3 different availability zones in the same region. So with the Aurora, basically the compute and the storage are decoupled. So the read replica is kind of acts as an interface to the storage layer, which does not keep copy data to the replica itself. So when the primary instance is unavailable, Aurora will automatically fail over the primary to one of the read replica with a better failover priority. The failover is under 1 minute. The Aurora has provide different types of endpoints to manage connections. So we have for instance, use the cluster endpoint to perform the write operations on the primary instance, and use the reader endpoint for the read-only request that's load balanced across all the readers in the pool. And for the clusters with instance of different capacity or for specialized purpose, we can also define the custom endpoint for different groups of instance in the cluster. Here, some of the pros and cons of running Aurora MySQL at Venmo. So it's managed services. Basically, we don't have to worry about provisioning the hardware, and the database, the data is automatically backed up on the S3, and the Aurora read replica has a very low latency, under 100 milliseconds, and the average is about like 20 milliseconds. We are seeing better performance, basically 3 times better performance improvement after migrating to Aurora, and it's basically this cloning, like a 10 terabytes database takes about 2 to 3 minutes, and adding an additional replica to the cluster takes about 5 minutes. And the custom endpoints, we talk about that. The monitoring tools, so Aurora provides a variety of monitoring tools, like the RDS console, the Cloud Watch, and we have tons of Aurora metrics to manage the to monitor the resource usage, query performance, and also the replication latency. And we also enable the performance insight, which is easy to understand dashboard, which basically help us to detect, visualize the load on the cluster and easily to detect and diagnose performance issues. Some of the cons, while it is managed services, so we kind of, it's hard and difficult to know what's going on in the backend system and storage layer. The cluster can have up to 15 read replica, and also the cluster volume only goes up to the 64 terabytes. And also when we restart the primary instance in the Aurora cluster, basically cause all the readers in the cluster to reboot as well, and that will have a brief interruption of the read and write operations. So that's something to have to be carefully planned when we restart especially the writer node. Okay, so with that, I will turn over to Van to talk about the scalability challenges at Venmo.
Thank you. I have a friend at Venmo who's like to think positively. So every time I mention our infrastructure or our challenges, he would change the word challenges to enhancement or feature enhancements, performance enhancements. So as you notice, we have lots of enhancement opportunities last year. Some of the quote-unquote enhancement opportunities falls in scalability. We were using a monolithic MySQL cluster with one writer and lots of reader nodes, but we were not using the reader nodes appropriately. We were not sending all the reads to the reader nodes, and as a result, most of the reads still fall to the writer, and that certainly would not scale. We were also using a very old version of Aurora, as well as MongoDB and Cassandra. We had DR set up in the West, but it's not fully fleshed out, so we can't really do a full failover. And as a result, you can see it impact our user. It create bad user experience, higher volume to our customer supports, and we did receive pretty bad user rating in the App Store last year. And ORM are great to use for developers. It's helped them generate queries. For DBAs, it's pretty bad because it can generate pretty badly performing queries. And as you see, we indicated here, our top 10 slow queries generate at least 75% of the latency that we experience on the writer. Over the years, we changes our access pattern, and as a result, many of the current index, could not be used by our application, and we experienced exponential growth in data for the last few years to the point where we can't really add covering index to larger tables, even if we were using PT online schema change or Ghost. It would take us weeks just to add a covering index on a large table. And most of them are payment table, which affect our payment rates. We didn't really have a data retention policy for any of the data stores. As a result, many of the key space in Cassandra would not optimize, configuration would not tune. The same thing is true with MongoDB, where we have lots of large collections that we didn't optimize, and for the longest time, we didn't have a DBA team at Venmo until last year. It's incredible when you think about it because Venmo have been around for a long time. It was always a small company, and Venmo was able to handle huge amount of payments. Last year, in the first quarter, we handled something like $12 billion in transaction with a very small team. It's just that near the end of the year, we start experiencing exponential growth. And it resulted in exponential growth in our data, our user base, and as a result, we see a lot of problems. Also because our payment flow involved multiple database, we were seeing high number of deadlocks as well as blocking reads. And all of that resulted in pretty bad performance. Some of the operation challenges that we face include having lots of monitoring tools, but we only keep track of basic monitoring. As a result, it's very difficult for us to troubleshoot when there's a problem. And as I mentioned, we've grown from a very small company to an enterprise platform, and we want to grow into an enterprise platform. And as a result, initially we didn't have a dedicated release engineering organization. QA was very limited, and the DBA didn't really get involved until the last minute when we were asked to create data models on production. And of course, we didn't really go through and do proper code review like you should do, as well as query tuning, lack of sufficient testing. Basically, it's growing pain that any small company would face. And now I'll hand it over to Heidi.
Just like the Black Friday and Cyber Monday for most of the e-commerce applications, that's the most crucial time of the year for most of the e-commerce applications. For Venmo is Super Bowl. So Super Bowl is the biggest event of the year for Venmo, which brings massive increase in the site traffic. So here is a sticker that shows the Venmo's 2018 transaction pattern on Super Bowl. As you can see that there is a huge spike in the traffic after the coin toss, and after the end of each quarter, the halftime, and with the end game brought the largest load to the site. So the projected volume increase in peak volume in 2019 is 2.5 times higher than 2018. So to meet this dramatic increase in the demand, also while delivering a good user experience, the Venmo team planned well ahead of time to prepare for the event. So just like Don mentioned, a task force was formed with various teams in Venmo and also PayPal for the couple of months leading to the 2019 Super Bowl. The team analyzed the Venmo system for potential bottlenecks and implemented a lot of short-term tactical improvements, and the outcome was very noticeable. So with the proactive preparation, Venmo was able to achieve the projected volume for 2019, and this is the profile for 2019 Super Bowl. So some of the principles for the short-term technical improvements, we're trying to target the availability improvement during the Super Bowl and minimize the code change without making big surgery on the data models. And we want to align the short-term with the long-term strategic moves such as the domain isolation and rewrite splits, and that is our the long-term goal. We'll quickly go over some of the infrastructure scaling and the application optimization. I'll turn over to Van to talk about the operation and release management enhancement. So for the infrastructure scaling, first we want to keep our Aurora DB engine up to date to apply the new features and also fix bugs. So the team performed the Aurora upgrade from 1.16 to 1.17.7 with the MySQL 5.6 compatibility. I will show the upgrade basically improved the DML latency. As you can see, that's the before the upgrade, after the upgrade, and we're seeing the reduce the block transactions. For the binlog replication, we changed from the statement-based replication to row-based replication, which reduced the binlog replication lag to our analytical and reporting database. And also, it made it possible to do online schema change for large tables using tools like Ghost. We did a vertical scale of the writer node. So basically, double the CPU and memory and use the enhanced IOPS and the networking performance. So with a CPU-bound application, the vertical scaling basically efficiently increased the capacity. On the reader nodes, so we scaled up the reader nodes and also scaled out by adding additional reader nodes. So the team also focused on rebalance with the additional compute power. The team also focused on rebalancing the read-write operations requests, offloading the non-time sensitive reads from the writer node, so which reduced the CPU utilization on the writer, maximize the DML throughput on the writer. For the domain isolation, so to improve the InnoDB buffer cache efficiency, instead of doing round robin and evenly distributing the read request to all the readers in the pool, so the team worked on the query affinity to dedicated groups of readers by domain. So basically, we separate the readers in the cluster to different groups, like users, risks, or payments, and each group has its own custom endpoint. So we kind of use this as a precursor for domain isolation, and basically to keep each domain on its own dedicated cluster, which is aligned with our long-term goal. On the application optimization and query tuning, so I will just go over some of the lessons we learned. It is important to not only identify and tune the slow queries, but also the heavy hitters, so which are the most impactful queries that has a large number of executions with a high resource consumption. So tools like PMM and performance schema and performance insight help us to identify the heavy hitters. And we've talked about the ORM can generate insufficient SQLs. So it's very important to review the application code and also the SQL generated by ORM. and to reduce some of the insufficient SQL and unnecessary DB calls. So for example, it is very costly to make 2 DB calls in the database to count the number of rows first, and then do the get the result set back. And also, the queries work for some bind variables, may not necessarily work other bind variables due to the execution plan change. So be aware of some of the optimizer bugs, which can affect the execution plan stability. The last one is on Aurora read clusters. The Aurora cluster, a long running slow query on one reader node can affect the writer performance and also the other read replica on the cluster. So this is something that to be aware of. I will go over just a few use case. So here we have, this is one of the heavy hitters on all the user, the read clusters. And this is a single table select. So in general, it's inefficient to retrieve a large set of rows back from the database and then filter within the application. In this case, is actually when the input user is none, is blank, and the queries are executed without the user predicate. So basically, it scans millions of rows and returns tens of thousands of rows back to the application, and the application then filter again against none, and then return a end result of a none. So basically that's unnecessary but very costly. The fix is actually pretty simple. Is when the input user is blank, is none, then just return none without applying the logic, and basically eliminate the execution of the problematic query. So after the code fix is deployed, we noticed the 25% of the CPU reduction across all the reader nodes. So by fixing this one query, we're seeing substantial improvement. So sometimes less is more. Here we have a slow query that joins 7 tables. And it uses a driving table's primary key to and limit order by limit 1 and descending, and to return the most recent users created that meet the criteria. So when the runtime of the query is in milliseconds, when it's using the proper index on the timestamp column, which is part of the where clause. But it can take up to 180 seconds when it's using the primary key index to scan millions of rows, which cause the application to time out. So there are several bugs related with MySQL optimizer, which for the order by limit n type of a query. So it favors the index on the order by column, even though it's not part of the condition in the where clause. So the fix is actually, it's a workaround, basically. So it uses the, basically we change the query instead of ordering by the primary keys, primary key column, we change the ordering by the primary key ID by the timestamp column. So basically, the results returned back to the application should logically be the same, because the primary key is a auto increment number, and it increased monolithically. So the larger ID means the user is created more recently. So with that change, the performance of the query is consistent. We're no longer seeing the timeouts here. Okay. This is the use case that we have an hourly batch job that's running on one node of the one reader node in the cluster. It's affected by a long-running query on a different node of the cluster. So when there is a long-running query, the list of so the index page merging on the secondary index gets blocked, and the number of index count keeps growing, and the optimizer cost is also keeps growing. And when it overs the threshold, the optimizer picks the suboptimal index and affects that hourly critical batch job. So what we learned is when you have a long-running query on one reader node, it could affect the performance and stability of the entire cluster. So we come up with a automated approach solution to detect a long-running query, read-only query, and terminate the read-only, long-running read-only query to improve the performance of the cluster. So with that, I'll turn over to Ben.
Thank you. The key point in this slide is that we start to make better use of current data analytics and predict peak time, peak hour, peak season, and scale our infrastructure appropriately. The one thing that we notice is that we can't account for every scenario, and let me tell you a true story that happened a couple of years ago. A few years ago, during one of the nationally televised football game, while the announcer were discussing the game, one guy in the background held the sign and said something like, "Dude, I need beer money, please Venmo me." And people actually sent him money, and it causes a spike in our system. Now, we could never account for that type of pattern, so we need to scale our platform just to take into account the events where people would be begging for money, which also means that all of you could also beg for money. We don't recommend using our apps for that. I'm sure there's a GoFundMe app somewhere that you can use. But going back to my point, as part of the improvement, operational improvement, we created war rooms and set aside Slack channels, dedicated bridge, especially for handling peak period. We also created the performance and scalability team to architect, to remodel our infrastructure, to scale our infrastructure. We made major improvement with our API and how we talk to PayPal to improve our risk bars. We also introduced a really cool feature called feature flag. So every code release requires a feature flag. And if, for example, we notice that we have problem with that particular feature, we can just enable that flag and disable the code. We don't have to roll back. We don't have to worry about problems that's associated with rolling back and dependencies. It's also a great way of introducing new features. We tested the feature, we roll them out, and if there's a problem, we disable it. We go back, fix it, produce a patch, and enable it again. We also make better use of we have a lot of cron jobs, and depending on the peak time, we'll move the cron job back and forth just so that they don't run during peak hour. We also made a lot of improvement in our release process. We starting to play with the introducing a canary environment where we roll out certain changes and monitor it, and if it's great, then we start rolling out to more environment until we roll out the full thing to production. We also introduce incident management. There's an on-call incident manager that rotate every week, and we made major improvement to on-call, including DBA on-call. We made major improvement in building up our load test environment to improve our QA process, and now DBA actually involved in projects early in the design stage of the project. So we have a say in how we design the data model, as well as running tests and detecting query pattern. The key is really when we release code to production, we know what to expect. And as you can see here, the key metrics really is the HA, the high availability. That's incredible to move from 1.9 up to 4 nines in a very short time. It's very difficult to do, but we did it. A lot of the things that we did last year is more of a technical solution. Our long-term solution involved scaling our database horizontally. That's going to involve doing microservices. That's involved taking some of our heavy hitter tables and shard them using Vitesse. We also introduced data life management. We review our data and identify which data can reside in the operational tier or the warm tier, or if we can delete some of the data. We also made major improvement to transactional integrity. We're moving some of the component within our payment flow out to their own domains to improve performance. And the key is really we're making incremental improvement instead of making wholesale changes. And our goal is to really scale linearly to 100 times what we're currently facing right now. And it's almost, and every year during the Super Bowl, our growth increased almost 2.5 times. It's not linear growth. So this year, we could be facing a lot higher growth than that. With that, we conclude our presentation, and we'll open up the floor for questions.
Can you talk more about how you review queries before they go to production?
Yes. I think Heidi brought up the fact that we're using AWS Aurora, which is great because it's a managed service. And the bad thing is it's a managed service, which means we can't see on the back end. We don't have access to the full spectrum of monitoring. So a lot of times what we would do is we would set up an EC2 instance if we need to have the full spectrum analysis. And so we run our payment flow through EC2. We capture all the data. Currently, we're testing the use of PMM as well as Vivid Cortex, which means that you have to enable all the weights events through the performance schema, and that's how we do it. We look at the slow queries in the performance schema, we improve the performance, do it all on load test before we roll them out to production.
I may have actually misunderstood the slide. I thought you said that one of your key strategies was to review all queries before they were, or is that what you're saying?
Yes, review all the queries before production. Of course, we can't review all queries, otherwise DBA would spend all our time reviewing queries.
Just focus on the slow queries from your EC2 testing.
From Aurora, yes. And then also, as part of the improvement that we currently make to QA, all the release will be run on Dockers. It will be running on a Canary system, and then we have all the monitoring set up so that if there's a flag, we'll get alerts, and then we start taking a look at the slow queries, and that's the best way to scale tuning your queries. Otherwise, we don't have enough DBAs to just go over and review every slow queries. Yes. Yes. Yes, that's a great question. In fact, that's why we were looking at using proxy SQL or HA proxy, so that you can use binlog replication, and you can create multiple number of cluster that replicate from the production core, for example. And when you do maintenance, you would do the maintenance on one of the cluster, and then fail over. Yes, that's one of the key challenges of using Aurora, because the Aurora team also looking to do away with binlog replication. I don't know if you heard about that. So right now we're using binlog replication to replicate to analytics, and we're in a process of using binlog replication to replicate to other clusters, so we can do failover like we used to do with the EC2 instance or a standard MySQL instance. I don't know what would happen if Aurora take away binlog replication. That would create problems for us, and we'll probably have to take a look at different technologies. Yes, in fact, Airbnb faced similar problem like us. They were using Aurora. What they did was they create several cluster, and they replicate from their main cluster to what I would call a maintenance cluster, and they would do maintenance on that cluster and do fail or use proxy SQL or HA proxy to redirect traffic. That's how you would do, or how we plan to do it. Yes. Okay, there's two ways we're looking to scale our MySQL cluster. One is to do microservices. That means going through our payment flow and determine which component can we decouple, and then put them into their own domain, and then shard the data. We're also looking at Vitess to help us shard some of the larger MySQL tables. That's on my to-do list. Yes?
So because you are using Java, right? So when you Java, usually it's migration for the ETL. So how do you coordinate with the migration and your code release?
I'm not sure I completely understand the question.
Yeah, because when that Java migration will usually take a long time when you do the add table. If you are adding the table for most likely for a long time, for like 1 hour or 2 hours, right? But during that add table, the code was not released, and you have this issue.
How are you running migrations? Are you using the Java migration, or are you using another tool for migration like Lightwave or any other migration? Or is the DBA that goes and applies and migrates it, the SQL file?
Oh, you mean the data model changes that we do? We do ourselves. That falls on the DBA. The reason for that is because, well, DBAs are responsible for the data as well as the database, so I guess our leadership decided that it's better that we handle all that part.
Yeah, I don't think we were using the Django migration to do the EC migration.
No.
Java
No, and there's a problem with using the Django migration too, because many of our tables, especially payment tables, are quite large. It's in the multi-terabyte size. And if you're using a framework to do the migration, you don't take into account how long it would take for you to migrate. It's better to have DBA be responsible for that. Yes? Okay, for us, one, you need to set up alerts to identify slow queries. That's the first thing that we did. We set up alerts, so DBA would get the alerts, and then we start looking into the slow query either through the performance schema or the information schema, and then we take out that slow query, we start tuning them. At the very beginning of last year, we faced a lot of that. We're a lot better now in terms of setting up, I wouldn't say alerts, but notification for slow queries. The slow query would get sent to Slack as well as being paged to DBA. So higher up would monitor the Slack channel, especially the MySQL slow queries channel, and if we don't get on it, we don't fix it, they'll come and look for us. So that's one of the quote-unquote improvement that we made. It just make everybody more receptive to tuning queries and improving our payment per second.
So that happens because of Aurora shifts.
Yeah. Yes, that's the one thing that we noticed, that a really bad slow query on a reader could affect the performance of the whole cluster. That's why you need to tune all your queries. It just don't, you need to keep in mind that anything that happened to one node within the cluster can affect the whole cluster.
Yeah, I want to add a point here. Sorry to interrupt. That when you tune a query, not just focus on tuning the query itself, right? I think you should ask whether or not this query is needed or not.
Yes.
Right? The best thing is to eliminate the problem rather than change a query from executing from 5 minutes to 10 seconds. If I eliminate that, which is the example that Heidi showed, by changing one line of the code, we are changing the logic. We are verifying the input. And if the input is invalid, we don't even bother to execute the query.
Yes.
That's the best outcome. So that's why we can just change two lines of one line, two lines of the code, and reduce the 25% CPU across the board. So that's the biggest thing you can gain.
And we continue to do that, which means that DBA have to work very closely with the developers from various different teams. In fact, that's we're starting to have daily meeting with various different teams, and there's some days I have 7 meetings. All of them takes at least an hour. I don't know how I work, with just having so many meetings. But what that does is actually getting all of us to get used to working together, because tuning queries is not just the job of DBAs. It's involved the developers, it involved a data architect, because sometimes we need to change the data model itself. So you have to take a holistic approach to tuning queries.